So we're going to start chapter 3, which is going to deal with solving quadratic equations. And there are many different ways to solve quadratic equations. And we're going to look at some of the more basic ones in section 3.1. And today we're going to focus on solving quadratics by graphing. So here, one thing that I want to make note of is just some vocab. We want to find the solution to our quadratic, which is the same as finding the root. So those two terms are interchangeable. And for today, we're going to focus on graphing. So there are other ways to find the solutions. Here we've got using square roots, which we'll see tomorrow, factoring, which we'll see later this week. So I'm not going to concern us with these steps here because you're going to see them again. But if we're solving by graphing, we're going to find the x-intercepts of the quadratic function. So essentially, where does it cross the x-axis? That crossing point is our root or solution. So here, to solve quadratics by graphing, we're going to graph that quadratic. So using the same methods from chapter 2, most likely you're going to start by finding the x-coordinate of your vertex using opposite of b over 2a. And then you'll make a t-chart to find some remaining points. And then you're looking for where does the graph cross the x-axis. Those are going to be your roots or your solutions. So we're going to look at a couple examples. This first one here, x squared minus x minus 6. Whoops. Let's see if we can go back here. Okay, so x squared minus x minus 6, we can go ahead and graph this using the x-coordinate of the vertex is opposite of b over 2a. Here, a is equal to 1 because it's a 1x squared. B is equal to negative 1 since it's a negative x. And c is equal to negative 6. So to plug into this x-coordinate of the vertex here, the opposite of negative 1 is going to be 1 over 2 times a, which is 1. So x-coordinate of the vertex is 1/2. Y-coordinate of the vertex, you can plug that 1/2 into your calculator, or we can go ahead and just do the substitution here. 1/2 squared minus 1/2 minus 6, so square the numerator and the denominator to get 1/4, minus, we're going to need a common denominator here. So I'm going to multiply that 1/2 by 2 over 2. So it'll be 2 over 4, minus, this 6 is 6 over 1. So if I multiply by 4 over 4, I get 24 over 4. So the y-coordinate of my vertex, if I do this subtraction, 1/4 minus 2/4 is negative 1/4. Minus 24/4 is going to be negative 25/4. And then at that point, I would say convert this either to a mixed number or improper fraction. Mixed number or decimal. So negative 6 1/4 or negative 6.25. So I can go ahead and graph that vertex. I've got a point at 1/2. And then negative 6.25. And then I know that my quadratic is going to open up this way because it's a positive 1x squared. And I also know that then I'm trying to find where it crosses the x-axis. It's probably not going to cross the x-axis at like 1 or 2 because that's relatively close to that vertex. And this is a 1x squared. So it's not going to be super narrow. So for my t-chart, I'm going to put my vertex in the middle. So we had a 1/2, negative 6.25. And then I also want to pick x values that are nicer numbers to plug in. I don't want to pick any fractions or decimals. So as I said, it's probably not going to be crossing at 1 or 2 because that's going to make this quadratic really narrow. But maybe I pick 3 just to test it out. That's 2.5 units to the right of my vertex. If I go 2.5 units to the left of my vertex, that puts me at negative 2. So if I want to find the y value that goes with x equals 3, I have 3 squared minus 3 minus 6. So that's 9 minus 3 minus 6. 9 minus 3 is 6, and then 6 minus 6 is 0. Here's a 0. We could plug that negative 2 in or just use the laws of symmetry to know that it's going to be 0. So I can plot those points. Here's negative 2, 0. Here is 3, 0. And I have my quadratic. My solutions are the points where my graph crosses the x-axis. So I have a solution here and a solution here. I don't have to list the whole ordered pair. I can just say x is equal to -2, x is equal to 3, because that's really what I'm interested in. This is one of my roots. This is another one of my roots. Here's another example. First thing I will point out here is that this is not written in standard form. So write it as -2x squared minus 4x minus 2 equals 0, so that you can clearly identify A, B, and C. Then we can find the x-coordinate of the vertex. Same idea as before, opposite of b over 2a. So opposite of -4 is +4 over 2 times a, which is -2. So it'll be 4 over -4, or -1. I want to find the y-coordinate of the vertex. So I'm going to plug -1 into either the original or my standard form here. So -2 times -1 squared minus 4 times -1 minus 2. So -1 squared is +1. +1 times -2 is -2. -4 times -1 is going to be a +4, and then minus 2. So -2 plus 4 is going to give me 2, and then 2 minus 2 gives me 0. So my vertex is located at -1, 0. And then at that point, I know that's my vertex. I also know my graph is going to open down since it's a -2x squared. So here, I could graph some more points, but I know my graph is going to go like this. So I don't even have to graph any more values. This is my solution. I only have one. That solution is x equals -1. So you have some problems in your book to do for homework tonight. They're all going to be graph the equation and then locate those x-intercepts. And then tomorrow we'll learn how to solve by taking the square root.